Hello everyone, this is Algebra for Faith. Today's lesson is for May 14th. It covers 11.7, multiplying and dividing radical expressions, which you can find on page 464. We're going to go over the basic concepts of what it is, make sure you understand it, and then we're going to go right to your quiz, which is your last quiz of the year, 11.7, 11.8, and we're going to go over some problems from that quiz that's referring just to 11.7. So let's go to the Lord in prayer and then we'll get started. Heavenly Father, we want to praise you and thank you for all the many blessings you've given us, but especially for your Son that was sacrificed for us in order for us to have salvation and in order for us to live with you forever. We want to pray for our world, pray for those who are sick, those who are lost, those who are homeless, and we just pray that you'll just grant us wisdom of heaven. We love you. In Jesus' name, amen. All right, guys, so multiplying and dividing radicals, we're going to start out with a little lesson opener and where we're multiplying and multiplying mainly polynomials, and you'll see why we're going over this as we get further into radical expressions, because basically when we multiply radical expressions, it's kind of the same thing we do when we're multiplying polynomials, but you might have completely forgotten how to do that, so I'm going to go over it real quickly. So we have 5 times x minus 9. So this is a binomial. I'm multiplying it by a monomial, which is 5, and I need to use distributive property to make sure that the 5 is multiplied to both the x and also the 9. So I'm bringing this a little closer. No, maybe not. That's not for good view. So 5 times x would be 5x. 5 times a negative 9 would be a negative 45. Then I'm multiplying 2 binomials together, and we did this in the last chapter. This is multiplying 2 binomials, maybe it was the previous chapter, I can't remember, is using the FOIL method. So I'm going to use the multiply the first term, remember FOIL, F-O-I-L, multiply the first term, that would be 4x squared, multiply the outer terms, that would be 28x, multiply the inner terms, that's a minus x. I don't know, did not need to put a 1 there. Where's my eraser? I'm like going crazy. That would just be a minus x. I mean, the 1's fine. And then finally multiply the last term, that'll be a negative 7. Then these two things here are like terms, so I'm going to put them together. So that's going to become 27x minus 7. That is a trinomial, and you get trinomials when you use FOIL. You should end up with a trinomial most of the time, but remember we have some special patterns. Going down here, multiplying 6x to the binomial x plus 1, monomial times a binomial. So 6x times x would be 6x squared. 6x plus the times the 1 would be a plus 6x. I cannot put those together because they are not like terms due to the x squared. Then these are 2 binomials that I'm going to multiply together, but that was a special pattern. This was a square of the difference. So square of the differences means I'm not going to come up with a trinomial. I'm going to come up with a binomial because my outer terms and my inner terms are going to cancel each other out, or I'm going to subtract them and it just becomes 0. So basically, with that, I know that all I really have to do is multiply the first term, that's going to be 64x squared, and multiply the last term, which will be a negative 81. That's only true for something that's the square of the differences, one of our special patterns. This was a special pattern too. That was a perfect square. The perfect square, I am going to get a trinomial, if you remember that from earlier. If you're completely oblivious as to what to do with the perfect square, write both of them out and use the FOIL method. You're going to get the same exact thing. But basically, this perfect square is going to come out to 9x squared, right? 9x squared, then the middle, if you remember what happened, if this term's negative, my middle term is going to be negative. It's basically me multiplying that this term to that term and then doubling it. So I'm multiplying the negative 2 to the 3, that's a negative 6. Then I'm going to double that, so that becomes a negative 12x squared. Not square, just a negative 12x. And finally, these last two terms, the negative 2 times the negative 2 would be a positive 4. So that's us just briefly going over multiplying polynomials. As you see on page 464, when you're multiplying radicals, it follows the same rules that you follow for multiplying polynomials. Then after I multiply the radicals, I do the same thing like I did with the multiplying polynomials. If I have some like terms to put together, only in this case, if I have some like radicals, I'm going to add or subtract those together like we did a couple of days ago when we're adding and subtracting things. So let's just go over some rules just to remember that when I'm multiplying a radical, just in case, all right, that really does not show up well, but basically we had this little thing, if I'm multiplying the radical of x to the radical of y, basically I could stick both of them underneath the radical sign, and that would be absolutely fine. And I could just go ahead and go to town and see, multiplying those terms underneath it. Well, that's kind of the same thing we're doing. If you notice, like example 1, you have two radical expressions. And a radical expression, guys, just means there's a radical in it. There's a number under a radical sign. So on example 1, they use the FOIL method using those two, I guess you could call it binomial radical expression, I guess you could kind of call that. So what I would like to do is let's use the example that's on your quiz, and let's see if we can figure this out. We're going to use the FOIL method. So if you'll look at the first problem on your quiz, it looks like this. I have the radical of 3 minus the radical of 5, and then I have the radical of 6, and then I'm adding the radical of 10. And what you want to do is you probably want to try to factor these down a little bit more. That's what we've been doing since then. None of these are going to. You're not going to find a perfect square under any of those. You're just going to have to go ahead and multiply, and we're using the FOIL method for that. And then if we can break stuff down, or if we can add like radicals together, we will at that point. So I'm going to multiply the radical of 3 to the radical of 6, which basically means I'm going to keep that radical sign kind of right there, and then multiply the 3 to the 6, so it becomes the radical of 18. So that's my first term. My outer term, I'm going to go ahead and just multiply the 3 to the 10, but keep it under a radical sign, so that's the radical of 30. My inner term, I'm going to go ahead and multiply the 5 to the 6, that becomes a negative radical to 30. You can kind of see what's going to end up happening here. Then I'm going to finally go ahead and multiply the radical of 5 to the radical of 10. It just basically means the 5 and the 10 multiply together, and it's going to stay underneath the radical sign. So in keeping like that, you can go ahead and see that these two just cancel each other out. So I don't need to worry about that at all. I'm done with it. This one though, this one right here, I need to go ahead and say, all right, are there some factors of 18 that would come out as a perfect square? And probably one of those you could just figure out right out of the bat. If not, we're just going to go ahead and say, all right, it would be 9 times 2. I could go ahead and put that under there. Now I'm going to pull the square root of 9 out to where it becomes 3 to the radical of 2. All of this is gone. I need to do the same thing to 50 right here. So in 50, and it's going to be negative, So what would be a perfect square of 50? That would be in there. Well, 50, if nothing else, guys, if you can just go back to a dollar is 4 quarters. 50 cents is 2 quarters. Oh, perfect square there, 2 quarters, right? So 25 times 2. The perfect square of 5 would come out. That would be a 5. And then I would keep my radical of 2. Well, these two are like radicals. So I could go ahead and add or subtract those together. So I have the 3 times the radical of 2, subtracting 5 to the radical of 2. If that confuses you, just go ahead and say I'm adding the opposite, or I'm adding a negative 5 to the radical of 2. Then I'm going to subtract, keep the sign of a larger absolute value number, which would be this one, right? And that's going to become, my answer will be a negative 2 to the radical of 2. Okay? You have another one on there. If you'll go on down, skip 2, that's a division problem. We're going to do that in just a second. Let's go ahead and go to your next multiplication problem, which is all the way down, I guess on 3. And it looks like this. We're still going to use that FOIL method. So this one, and you could probably just kind of look at it off the bat. This one's going to be the difference of squares, which means I'm going to end up with a binomial. But just we can just use FOIL method, so we can just take our time and make sure we get it. I'm going to drag this over here with me. So here I have the radical of 2xz. Oh, and then I'm going to have 2z. So that's my first one. The radical of 2xz minus 2 times the radical of z. Then that's going to be multiplied to basically its conjugate, which, no, it's not, it's different, never mind. So it would just be the radical of 2z plus the radical of xz. So yeah, that is not difference of squares. Just glanced at that, completely got it wrong. So we're going to have to use the FOIL method on this one. So I'm going to multiply the 2xz to the 2z, stick her under a radical sign. 2 times 2 would be 4. X is just going to come along for the ride. Z times z will be z squared. Then, what do we have? We have our outer ones. So our outer ones are going to be 2, just come out of the radical sign. X times x will be x squared. Z times z will be z squared. Inner ones, that one will be negative. 2 just comes along. This 2 will just come and stay out here. The 2 under the radical sign will just come along. The 2 z's will end up being z squared. So I'm trying to make sure I've got enough room because I feel like I'm getting out of the screen. And then finally, my last term will end up being the 2 comes along. Then I have x, see, there's an x, and then z squared. Okay, we have a mess here. We're just going to have to go by it step by step, okay? So right here, I have some perfect squares I'm going to go ahead and pop out. So that's what I need to do now, is I need to try to simplify each of these radicals. 4 is a perfect square, so I'm going to take the square root, and that's going to be 2. But that's not all. This is z squared. I might as well take out z too. Well, actually, not might as well. That's just how it's going to simplify. So that's what I'm doing with this first term. You can probably see what's going to happen on this next term. I have 2 squares under here. I need to go ahead and pop out that x and that z. That's the square root of x squared. The square root of z squared would be xz. So x, z, what's under the radical sign? The 2. Let's go to the next one. The z is going to come out because it's squared. So now I have 2z underneath the radical of 2. Then finally go over here. The 2 is going to stay. What's going to pop out? that's z squared. Z is going to come out to the radical of x. I'm still not finished because now I need to combine like radicals. Like we did yesterday or the day before, we combined like radicals. Right off the bat, my like radical is x and x, right? So we have x and x. And then when we try to put those, those two are just going to cancel out. So I have 2z to the radical of x minus 2z to the radical of x. Those just disappear or become 0. What do I have left? Xz to the radical of 2 minus 2z to the radical of 2. Well, these are like radicals, but they are not like terms because look, I have xz and I have 2z. If this was just some number with the z, I could be able to subtract it or add it or something, but it's not. It's a variable. This is my answer. This is all you can do to it. This is its most simplified version is right here. So we have done 2 of your multiplication problems. Before we go into the division problem, let's just talk about how do I divide a radical expression? Because it's a little bit different. And that's one reason why it's like, wait a second, this is multiply and divide, and all we did in the lesson opener is multiply, because guess what? When you divide a radical expression, you end up making it into a multiplication problem. So that's why we did no division. So it's almost like, yay, right? So let's talk about division. If I'm going to divide a radical expression, then basically, first of all, I need to make it into a fraction. So I'm just looking over how it reads a little bit. And if you still don't understand it, you can go over page 465 and page 466. But right there at the bottom of page 465, it goes over how to divide a radical expression. So basically, I place the dividend over the divisor, or basically I'm making it into a fraction. And if you notice your test question or your quiz question, they've already got it into the form of a fraction, so you don't have to do anything on your quiz like that. Once I get, once I have a numerator and a denominator, then I'm going to divide by multiplying the numerator and the denominator by the conjugate of the denominator. Because you can't have any radicals in that denominator. Remember us radicalizing the denominator, where we basically had to multiply with the radical, both the numerator and the denominator? Well, now I have to multiply it by its conjugate. And before you say, what's a conjugate? I just wrote it out here, or it's on page 465 too. What's a conjugate? Well, if a plus b, its conjugate is a minus b. So it's basically kind of the opposite, except if it's like this. Now, you can always, make the first thing negative or something like that. It's just going to make your life a lot more miserable. So, it's just adding you more steps. It's not going to necessarily make it wrong. It's just you're going to have to probably end up radicalizing the denominator as well as using the conjugate. So basically, when you think of a conjugate, if you have a plus b, then the conjugate's a minus b, or it's kind of the opposite of what that is. So let's go to your division problem that's on your quiz, and let's see how we're going to set this up. I'm picking up too many books. Going to go over here to my little blank spot that I have. In fact, I think I'm going to get rid of this as well. There. Now we have plenty of room, except I keep getting hung up on my cord. Okay, I don't like that either. All right. So if we go to question 2 on your quiz, this is a division problem using a radical expression, and we're going to divide it with a radical expression. So here we go. I have 6, and that's being divided by 3 minus the radical of 5. And then how am I going to divide that? Well, I'm going to divide that by multiplying it, both the numerator and the denominator, by the conjugate of my denominator. So I'm going to multiply the top by 3 plus the radical of 5. I'm going to multiply the bottom by 3 plus the radical of 5. And that gets rid of my radicals on the bottom. So let's look at what ends up happening. If I multiply 6 to the 3, it's 18. The radical of 5 just kind of comes along. And 6 times the radical of 5 would be 6 to the radical of 5. What happens here on the bottom? I have 3 times 3, which would be 9. Remember what happened when I radicalized the denominator? If I'm multiplying the radical 5 to the radical 5, it kind of pops out, or it becomes 5 squared, if you want to think about it, or it just pops out as the square root of 5. And then I'm going to just kind of fiddle with it and see what I can do. So this is going to end up being 18 plus 6 to the radical of 5. And then down here at the bottom, that's going to be 4. I am still really not finished with this because this isn't in the simplest of terms, as you can see. So basically, this number, this number, this number, they're all even. So I need to go ahead and break all of those down by an even number to make it smaller. 4 is not going to divide into 6, 4 is not going to divide into 18, so I'm basically going to reduce the 4, the 18, and the 6 by dividing all of those by 2. So if I divide 18 by 2, I have a 9. If I divide the 6 by 2, I have a 3. If I divide the 4 by a 2, I have a 2. This is my simplified version of that radical expression. If you've got this, that's fine and wonderful, but you have one more step you have to take. So this is the final answer for it. So that has gone over all the different questions we have on 11.7. If you want to continue to practice to get this into your brain better, you can continue on with some of your homework that you have for 11.7. Just do a few to see if you understand the concept. If not, we have one more day where I can't even think of what we're doing. Didn't look that far ahead. So your next one is going over just radical equations. Final one, 11.9 is radical functions, which we will not get into, sorry. But we will go ahead and cover up radical equations. And, a lot of people are probably saying, why is she even doing this? This is such a waste of time. It's because I want to cover as much math. Math is a building block, and I want to cover as much as I possibly can before you get into geometry, algebra 2, whatever your next step is. And you can always, if you didn't understand a concept, my YouTube channel is not going anywhere, so you could always come back and look over things. Have a great rest of the day. We have one more algebra lesson, and then we're through for the year. See ya.